Hello, everybody, and welcome to the Change in the Climate podcast. Of course, as you know, this show is brought to you by Climate Change Realty, the only real estate brokerage that donates 50% of its commissions to nonprofits dedicated to fighting climate change. If you are looking to create climate action on your next real estate transaction, all you have to do is visit ccrealty.org, and we will find you an agent in your area who's willing to offer 50% of their commissions to help save the planet. Now let's dive into the podcast. Subarna, Detelina, welcome to the podcast. Thanks so much for taking the time. I really appreciate it.
Thank you for having us.
Thank you. Appreciate that.
You're very, very welcome. And, we always like to get this podcast started with a little bit of background on who you are and how you got to be doing what you're doing at the current moment. And Detelina is on the left on my screen. So we're going to start with her. Why don't you tell us a little bit about yourself?
All right. Thank you, Ethan. Thank you for inviting us to talk to you and to your audience. So I'm an immigrant from Bulgaria, came to the US in 2000. My background is in physics, master's in meteorology, and PhD in oceanography. Through my academic career, I've been working both in US and in Europe. I built extensive expertise in climate modeling, climate data analysis, high performance computing. My highlights of my career are my postdoc at Lawrence Livermore National Lab, where I participated in a first-of-a-kind ultra-high resolution, fully coupled global climate simulation. Working at the Program of Climate Model Diagnostics and Energy Comparison at LNL, I was developing metrics and methods for climate model evaluation, contributing to IPCC climate change reports. Most recently, I worked at the Scripps Institution of Oceanography. I studied the predictability of the terrestrial rainfall using ocean predictors. I met my partner, Subarna Bhattacharyya, while working at LNL. And we found ourselves striving how to transfer this high quality scientific knowledge about climate to the communities who are most impacted by climate change. And that's how our company, Climaformatics, was born. I left my full-time academic job a year ago, and I put my efforts in our company for a year now, and it's very exciting. We are building a product for highly localized near to long-term climate predictions. And I'll give the word to Subarna to say a little bit about herself.
Subarna, take it away.
Thank you so much. Thanks for that kind introduction and mention, Detelina, and thanks, Ethan, for inviting us to this talk. So my name is Subarna Bhattacharyya. I'm originally from India and now settled in the San Francisco Bay Area. A little bit about my background. With a master's in pure physics, an MC in civil engineering, and a PhD in engineering mechanics, studying Indian rainfall data over 100 years using various advanced mathematical, statistical, signal processing, and dynamical techniques, I learned about climate physics in a sort of a reverse engineering sense, if you will, by analyzing the observed climate data and building models based on them. That already got my interest driving into the climate science. But then I joined a job at the insurance industry, and my brief stint there as a catastrophe risk modeler, modeling hurricanes and other natural and man made disasters, fueled my desires for learning global full scale climate modeling. And that's what got me into the Lawrence Livermore National Lab, working as a postdoc at the LLNL's Nobel-winning IPCC Working Group 1, modeling pathways and impacts of abrupt climate change, particularly from large methane emissions, gave me deep exposure into full-scale climate modeling and impact assessments. So, together with my experience in risk modeling and my skill sets in widely interdisciplinary applied mathematical modeling, analytics, and prediction skills, signal processing, and time series analysis expertise, it became seemingly obvious for me to be able to connect the dots. And that's where I met Detelina at LLNL, and we shared a lot of common concerns of how the vast knowledge of climate data science can be applied to help farmers, businesses, stakeholders proactively to make informed decisions, particularly the question of why we could not see the drought in California coming well ahead of time. is what got us thinking and started. And there you go, Climatematics was born.
Very, very, very cool. Thank you both for the excellent introductions. I really appreciate it. It helps me get the context. And I like that first question right away. How could we not see a drought coming? I guess my next question to either of you, to address to either of you, is how can we really see anything coming? How do these models or these predictions that scientists make, how do they come together to begin with? And do you have any examples of something a scientist has been able to predict with great accuracy? Because sometimes I look at the weather app on my phone and they say it's going to rain and it doesn't. So I'm wondering what examples we have where scientists are really good at predicting something.
So let me start by answering the question and let Detelina, get you into more detail about how climate models work. But just answering your question, I would just say that the current state of the art climate models are getting better and better, and they're pretty robust in modeling the climate states and the interactions between uh, the different parts that make the climate that talk to each other, like the atmosphere, ocean, land, ecological systems, glaciers, land ice, sea ice, and so on. We at Climatematics actually build on that technology further using our own AI and have been able to accurately predict temperature and precipitation in California for about 300 zip codes, about 30% of California zip codes over the period 2011 to 2016. And recently, we have also done solar power forecast validations over 2021 and 2022. And we have some live forecasts out there right now as we speak for about 10 locations in the US. So climate change is slowly compared to weather, and the dynamics is also reasonably well understood. And therefore, if we understand the system, the chances of our being able to predict what is coming in the short term, like more than the weather, beyond 10 days, beyond a month, to a year ahead, to a few years ahead, that can be a pretty robust understanding. And that's what we build on. But I would like you to know more about this from Detlina about how climate modeling generally works. Over
Definitely.
to you, Detlina.
Okay, climate modeling is my favorite topic, and please interrupt if I'm taking too much time. So I was coming to this interview, I was trying to find more simpler ways of explaining how climate models work, what it takes to run those models, and to produce all that information, which is telling us what is going to happen in the future and how to use it. So for me, in simple words, the climate modeling is the focal point of human knowledge about the Earth system. It includes physics, chemistry, biology of all Earth components like atmosphere, ocean, land, sea ice, and others. And the list keeps adding. And also includes all their interactions and feedbacks. Which are very important. For example, if we compare a climate model to a weather model you were mentioning, the weather model only has one component, the atmospheric component, and their forecasts are only probably accurate in the next 2 weeks. That's the short-term synoptic scale, which the atmosphere is a main driver of. In order to be able to predict longer variability, like seasonal or annual variability, you need to have the ocean, for example. That's the one which drives the El Nino, La Nina, together with the atmosphere, of course. And all that interaction is needed for a model to be able to predict seasonal variability, annual variability, and of course, a longer term. And that's what we're doing with the climate model development. And it's in continuous development. We evaluate, validate, improve the climate models with the ultimate goal that one day we're going, in the distant future, we're going to generate a digital twin of the planet Earth, which will be reproducing the reality as it is. Currently, the complex equations of this model are solved with the help of big supercomputers. in order to be able to use those, we need to discretize the otherwise continuous environment of the climate system into special grids, model grids. So that discretization itself already introduces an error. That's the model error, because what is discretization? That's the distance between two grid points. Anything with a scale less than that distance, it's not resolved by the model. So this is what we already know. We're counting for the model error. And I'm mentioning this because later I want to say why we have more accuracy. So this is the problem with the model errors. But current generation climate models, for example, the resolution is 1 degree, the standard resolution, and that's about 100 kilometers. So everything with scales less than 100 kilometers, like storms, tornadoes, clouds, or ocean eddies, it's not well represented by the climate models. Even though they're developing continuously, they still have some underrepresented physics. And there are development of high resolution models. As I mentioned, I worked in my postdoc on ultra high resolution, which was 10 kilometer resolution in the ocean and 20 kilometer in the atmosphere. But those are really expensive models to run. And we are far away from the time when we can run those models operationally, like the weather forecast model. So,
Gotcha.
So, do you want to add this thought to what you just said, Detelina? Going back to Ethan's question, that when he sometimes compares the weather forecast that he sees on his phone, and it doesn't match with what is happening outside when he looks out. Do you want to address that question as to why maybe not all the forecasts are taking into account the whole atmospheric physics? And that is possibly the reason that we, in spite of all our efforts, we do not get to see accurate forecasts of weather. It really depends on how the computation has been done, whether it has been a high resolution model, whether it includes all factors and things like that. Do you want to elaborate on that?
um, you mean the weather models? Why
Yeah,
they might not be correct? Well, I was saying that because they're not really having all the interactions with the rest of the
right.
components, they cannot represent correctly the entire Earth system physics. But it also depends on a very chaotic nature of the climate. So a lot of possibilities are possible, and depending on how fast we assimilate the observations, the models might lack the current trajectory.
So, am I understanding correctly that it's easier to predict broad global climate than it is a specific area? Like you said, for example, 100 kilometers or 10 kilometers. If you were to look at the city of Los Angeles, it'd be harder to predict the climate for Los Angeles than it would be for the whole country of the US. Is that what you were saying as well?
Yes, yes. Having a coarser resolution grids are allowing us to speak for larger area climate rather than localized, local for the city or local for a farm. And so far, the current services, national services, are addressing globally the problems. So they don't really look into the individuals' issues and needs.
Gotcha. Well, that might be a useful thing to obviously try to get into in the future. I'm trying to wrap my head around this as a business person who doesn't have a scientific minded brain at all. I think I try to think about things in terms, for example, of like investing. I can tell you that your house is going to be worth more money for sure in 30 years, but in the next 3 years, I don't know exactly what's going to happen. I'm trying to relate that back to like the climate model. We can say for sure we know broadly that the average global temperature is rising, which is causing ice to melt, which is changing the patterns of the ocean currents, and that's going to throw things out of whack. But we can't necessarily say exactly what's going to happen in the next 1 year because there's too many moving parts, kind of thing. Does that kind of make sense? That relation?
Yes. And actually, further to that, your question of whether your house prices can rise for 30 years, for sure, but will your house suffer damages in the next 3 years? In the next year, are you going to be hit by
Right.
a storm?
Right.
Do you need to retrofit for wildfires? So things like that can benefit. Questions like that can benefit from our kind of work, which we are trying to bring to the industry, to the commercial market, where we can use our climate models data, we can use them judiciously with our own AI, which is what we have developed, to give far more localized, accurate predictions that can help you prepare for those conditions. And because you will be prepared, you are expected to reduce your risks and therefore thrive. That could mean, um, your house survives, your business survives, your bottom line thrives.
Gotcha. So let's talk a bit about more about this. So you both have started a company separate from working for like a research organization. You started this company, Climeformactics, and who is like the end user of the data that you are calculating, I guess.
So, currently, you're asking who our customers would be.
And what the business is, how it works, why it exists, all that stuff.
So, in terms of customers, we are actually first focusing on the agricultural sector. In that, we are particularly interested in the ag tech companies who transact a lot with the farmers and the farming communities. And we are setting up our platform so that these ag tech companies can be our clients. They gain the data that we can and the insight from the knowledge using our app, and then they can tailor that app or to reach out to their customers with instructions like, okay, the next few days or the next few months you're going to have a heat wave, so you have to prepare for this. So advanced notification they can send to their customers, and we in doing so they will gain their business, and their customers will also save themselves from these unforeseen climate risks like heat waves, droughts, wildfires, and so on. And so active we are starting with actag because our goal was, our entire company started with the fact that we wanted to help the farming to be sustainable. But we soon find out that our customers are also the energy industry. Particularly, we recently went through a whole lot of competitions and award winning with the solar prize, which was a DOE effort, Department of Energy. And we now realize that the solar utilities would be our customers, because since the variable nature of electricity, particularly with respect to solar and renewables, it is extremely important to have good predictions and forecasts, both day ahead to seasons ahead to a year ahead, as to how much power you're likely to get and how that you can plan with respect to the existing demand supply, and how you can prepare other power sources, make your grid more resilient.
Mm-hmm.
So that's the other set of companies that we are currently talking to as customers. We are also, as part of our coming back to the agriculture, we are also initiated conversations with our wine industry, and that's where a lot of water intensive work happens. Their wine growing is far more dependent on the climate variables. I'm sure Detelina can tell you a whole lot more on that. But broadly, all the big industry verticals, whether it is retail, whether it is energy, whether it is sports, outdoor, entertainments, whether it is supply chain, logistics, healthcare, all of them are affected by climate change. So what does it mean if you're going to get a 1 degree rise in temperature within a certain time? And if that is within the short span of seasons to a year, how do you plan for that? How is your business going to get affected? Or are you going to get into big storms which are going to cause business interruptions in one place? Can you use that loss that you're going to have in one place because of the interruption? Can you make it up for another place where you wouldn't have those inclement weather? So all those kind of possibilities, whether it is a product launch, whether it is a promotion, whether it is taking advantage of the different climate scenarios in different regions, all of that affect the bottom lines of these companies. So
Sure.
all the big giants are going to be interested, whether it is Amazon, Google, Microsoft, or the companies of those kinds, or whether it is the retail, insurance, energy, water, tourism, healthcare, and all those other industries. Even the government stakeholder would be interested for their planning purposes. And we're very proud to say that we recently won this award from CalSeed, which is approved by the California Energy Commission, for a concept award for building this grid resilience, helping build the grid resilience using fire weather predictions. But California is particularly prone to wildfires, and
Oh
what we are
yeah.
seeing is that our ability to be able to predict this weather variables far ahead in time together can actually help us build a fire weather index well ahead of time for the government, the stakeholders, the Cal Fire people to take actions, to take mitigations so that we may not be able to stop the wildfires as such. And maybe we do not even want to get there because they're good for the forest in some way or the other. However, we do want to stop or minimize the loss of lives, the loss of properties, the loss of business in general. And that's our motivation. Along with that, we
Yeah.
have recently been members of United Nations Disaster Risk Resilience Chapter for the US. We are alumni of Cleantech Open, and of course, we still receive mentorship from the Lawrence Livermore, and we are grateful to be an IBM partner.
And I am grateful to have you here on the podcast right now. I think it's really awesome. And we could use some of your good data out here on wildfires in Colorado. It's getting just as bad as California, I would say. I am wondering, yeah, I know. So hopefully you guys start spreading out nationwide and we can use some of that delicious machine learning data to get prepared for some fires. I am wondering how this desire to help people get predictive data to be prepared for a changing climate led you to start your own business rather than create some kind of new department in an already established I don't know if it's a government body or a research institution. Where did the idea? I can see the market benefit, but I'm wondering where your desire to kind of take it on your own come from. Yeah.
So you are absolutely right. We first wrote our very first proposal and sent it to the government, federal funding. We
Oh.
got good reviews on our proposal, although it came back with the one serious comment that this is not a usual or a typical one solution fits all kind of a solution, because the different farmers have different needs for growing their crops. Right, somebody needs more water, somebody needs more heat, somebody needs less water, less salt, more salt. So depending on what you grow and where you grow, your needs are different. And so it's what we are building will help you cater to your needs, but the solution is as such not like you take the solution and it is broadly applied across everything. So it's a way of customizing the solution to the customer's need, and that is not really something that is aligned much with the science in nations interests in a theoretical way.
Okay.
And so we tried to start this from the lab, but it didn't work. And so we stepped out because we really were passionate about it and we wanted to really make a difference, and we believed that we could.
Yeah. Well, good on you. I believe that you can as well. You've definitely got the skill sets to make it happen. I think that's abundantly clear. I'm How is machine learning involved with the data and the models that you're developing, and how does that make them kind of more accurate over time? Because as I understand, machine learning is like a compounding effect where the longer time it has to collect, the better it gets. So it's just, the theory with humans, the longer we're on the earth, the smarter we get. But you could definitely bring that into question. But as far as the machine learning with the climate models, how is that directly involved?
Well, we will not be able to tell you a whole lot because that's a secret sauce
Oh, of
and
course.
IP.
That's why I had to
but
ask.
yeah, but broadly.
Hmm.
So the reason we are using this is simply because we hear a lot of things about machine learning these days, or that term is used, in a generic manner. But I just want to mention that we are not really using any of the off-the-shelf machine learning toolboxes as such. We are developing our own based on the basic science, physics, maths, and data numerical analytics. And based on that, we have developed our own learning algorithm, which will um, basically learn from the climate models and give us better predictions, and it will also address some of the subgrid processes which Detelina was mentioning. Maybe Detelina, you might want to say a little bit more on that. So basically, it addresses some of the deficiencies that the current state of the art climate models have, and so that's why that's what we are able to do.
Yeah, Detelina, why don't you tell us a bit about some of the issues with the current climate models and how yours is way better?
Well, way better. I don't know yet.
It's getting there.
But right. So I talked earlier about the subgrid scale processes which are underrepresented, which are introducing model errors. And the way we're trying to resolve this with machine learning is by using the climate data as model data as well. We are using a vast observational data available through different sources, either NASA or NOAA or NCAR, as well as we also using private observational network data. So by using this big data sets, we are able to fill in the gaps which are in the climate model solutions, at least at some level. The other issues we're addressing, besides the climate model errors due to missing physics or resolution, we also address the uncertainty which comes from the variety and the spread of the future climate projections. Like, for example, the latest IPCC report featured several different scenarios of possible future projections, climate projections. Like I think there were 5 at least.
Yeah, I thought so.
And all of those have variety of greenhouse forcing, aerosol forcing, as well socioeconomic development or land use. And that produces quite a bit of variety of solutions which might be possible to happen. So what we are trying to do, we are trying to, using current observations, to adjust these future projections to the most closely observed pathway in the now, because the projections of the models are at least 50 years ahead, but they are produced with some assumptions which may not be exactly what happens. And there are other factors like different forums happening now more and more often, like the Paris Agreement, like the United Nations Climate Conference of the parties, which are taking new decisions, new priorities. And it's not really clear what nation, what government will take what measures. So along the pathway, we just need to adjust the current observed climate state with the one which is projected. So that's the 2 main things which I believe our solution can improve in what's offered by the climate models.
Okay.
uncertainty and model accuracy.
Assuming we get to a point, maybe whatever, 5 years from now, or even now, where people continue emitting and the models keep giving us more and more negative data, how do you recommend people respond to the results that the model is producing, saying that in 15 years we're not going to have any ice in the Arctic Ocean, for example? How do you recommend people respond to that kind of stuff, I guess, or specifically perhaps business owners, when dealing with negative climate models?
So, I think this is such an important question. Um, I feel that when we have these results, which are seemingly negative, we need to delve deeper into it and understand the physicality of the uncertainty that these models are talking about. Usually, when we are reading an executive summary of of this huge research that goes into the IPCC report, we are only reading a little bit of it, and we are not really pointing our focus is not really to understand the assumptions that have led to that report or that analysis. Oftentimes these assumptions are extremely, let's say, aggressive. Like, for example, we would have, say, 4 times CO2 emission in the next so and so years. Now, the current reality may be different than that. And that's why there is a disconnect between what is happening right now, where we are right now, versus what we think would be in 10 years, 15 years, or 50 years. And that is exactly the reason why we are having these sort of uncertainties. So, one way to understand that is, are we understanding the assumptions behind these assertions? Or even if we do, can we understand the whole gamut of results? Can we look at the uncertainty as an ensemble instead of one point in space and time? And so that gives us a much more probabilistic framework, which the businesses can understand better. And that can give us a more realistic estimate of what is to be expected. But even with all of that, the current IPCC framework of reporting is not really geared towards businesses make that conclusion easily.
Mm-hmm.
And so that's why, part of our work is also to address those issues, to make sense of what the climate models are saying and what they're not saying, and how to use that information to get credible information for proactive risk mitigation. And so that's what people like us and businesses like us can help do, because we understand what the models are saying, we understand the math that goes behind it, and we know how to interpret that. And therefore, that's why we are able to work with those with our own algorithms to get a much more realistic, much more closer to observation predictions. And that's what the businesses would need to make informed decisions.
Yeah, I wonder if it's going to become more and more exceedingly important for any large corporation to be aware of climate
It
modeling.
is going to be.
Yeah, I mean, with a consistent, I don't know, the growth of, I don't want to say the growth of uncertainty, but extremes continuing to accelerate, being aware of this kind of stuff would seem more important than ever.
Absolutely. You see, with more number of wildfires, more number of storms, freezes, droughts, every part of the world we are getting exposed to this in a larger number of events.
Right.
And the insurance industry, which really is one of the safety nets, covering all kinds of adverse climate conditions, are getting to a point where they have to pay out more because the frequency of these extreme events have increased, right? And so, unless we come up with a mechanism where either the businesses take care of the climate information and act accordingly, adapt accordingly, mitigate their risks, or the insurance industry comes up with a way of underwriting and policies that will trigger the resilience by default, like say reducing premiums for all those businesses which are doing proactive sustainable risk resilience measures, so that they get an incentive, they have a lower premium, and they are trying to take care of themselves so that they don't get into large ticket losses.
Hmm.
And so it is going to be a central factor in how the businesses are going to survive and make money and be profitable and thrive. Without adapting for climate change, that is going to be difficult. It's already, we are seeing those results in the wildfires, in the floods and other disasters.
How common is it for large businesses to be paying attention to this stuff at the moment? And how does that trend compare to like in the past?
So they are actually, a lot of these big businesses are trying to use renewable energy, trying to have more greener solutions, are very mindful of their carbon footprint. And so with small steps, now all of these big businesses have separate programs on climate sustainability. They had, I learned that, at least recently I was visiting India, I learned that all the corporations there have to devote 2% of their earnings for corporate sustainability responsibilities.
Wow.
So policies like that are by default, ensuring that we have to take care of the climate, we have to take care of our environment, we have to pollute less, we have to recycle more. All of those are becoming mainstream now. So companies are definitely working towards that.
The government in India is mandating that all companies have to invest 2% of their revenue in sustainability.
Yeah.
That's very interesting. Hmm. What are the largest climate risks that American-based companies you think will be facing in the next 50 years? We've talked about fires. What else kind of comes to mind that businesses
We
need to
already
deal with?
saw so many examples. We saw repeated wildfires in the last 5 years here in California, in Arizona, in Texas, sorry, in Colorado. Um, I'm sure there are other areas, even in the up north, Pacific Northwest.
Hmm.
We have seen a lot of back to back large category storms, whether it is Hurricane Maria or, Harvey, you name it. There, Katrina, there has been so many um, large storms that have devastated these cities, brought down businesses. Every year, almost, we are having big cold freezes and really cold, severe climate in the east and the northeast. And so right now we are having all possible kind of climate disasters hitting this country,
Hmm.
whether it's in the north, whether it's in the south. The nature of it is different. Somewhere you're having a big wind event, somewhere it's a more atmospheric river event, somewhere it is drought event, somewhere it is fire event, but it is happening.
Right. Definitely. So based, you both have a robust understanding of how, I don't even want to say Earth, how the whole universe works. If you both studied physics and then got deep into your individual specifications, what steps do you recommend businesses and individuals take to mitigate some of the most devastating effects of a changing climate? I'd love to hear each of your perspective on this one.
Well, I think the first step is really to take responsibility for our carbon print and do everything possible what's in our capabilities to reduce our fossil fuels usage, use all the new technologies which are coming up, clean energy technology like solar or wind technology, power technologies, recycle more, use less trees for paper. That's the first thing coming up to mind. And of course, if you want to prevent, be just aware of this information, make yourself aware of fire weather alerts, like just now in the news, there's a new fire, coastal fire, which in the minutes, like 15 to 30 minutes, burn one block of houses, and people barely escaped. They didn't had alert at all. It was it's a devastating weather to have, and we have to be aware, and we have to be mindful and careful how we want to protect our property and businesses. I think this information has to be listened to, not just like the weather, but uh, like as well, like the weather have to be checked well ahead of time to know what is to come, and prepare as much as possible. Besides, yeah, there probably are different measures you can take to prepare for fire weather, which you can do on a regular basis when the temperatures are getting higher and the winds are getting higher. Um,
So
yeah.
I want to add to that what Detelina just said, that besides doing all that we can, like recycling, emitting less, and doing the basic each individual and company's part to help the climate. The other thing that is also emerging these days is what is known as a geoengineering.
Hmm.
And with that, a lot of these technologies are coming up, which are trying to restore some of the climate's extreme condition to a more normal condition. And while a lot of natural efforts in, like, planting trees, building the wetlands back to take the brunt of storms, and things like that are happening. But beyond that, there's a lot of effort right now with emerging technologies. And I would like to say a little bit about a different kind of a consulting work that we have been involved with, and we are very
Please do.
proud to be
Yeah, go
part
ahead.
of that. Detlina has been leading that work. So this is for uh, an effort to save the Arctic ice from melting.
Hmm.
And there's a nonprofit company which came up with the technology with a decade of testing, white sand-like reflexive hollow glass spheres.
The
um,
Arctic Ice
they
Project.
used to be Arctic Ice Project,
They were
yes.
on the podcast. Tom Light, this is the CEO of the
Oh,
company.
really?
Yeah.
Yes.
Okay, so yeah, so you know that earlier they used to be called ICE 911, and that's where we were both cleantech open alumni, and we were both at one point of time invited to speak. Dr. Leslie Field, the founder of ICE 911, which later became the Arctic Ice Project, she and me, we were invited to talk to a group of graduating students from the State Department, the Fulbright scholars and other scholars, as to what the Silicon Valley was thinking on climate change. What are the futuristic technologies that could help? And we were fascinated by the talks we had and the interactions we had, and we thought, okay, we are having detailed climate modeling background and expertise. At that time when we started the company, we did not even think that who in the world would need such highly catered skills. But turns out that they needed climate modeling because they needed to show what the impact of deploying their technology on the Arctic ice would be. And there's no other way to study that other than full scale climate modeling. And then we took up that challenge because we wanted to first see if at all anything matters. And that led to a beautiful set of work, a lot of research on good supercomputers. And that basically gave us the idea that yes, you can change the Earth's energy balance by implementing methods like that. And so, one of our pet ideas is that by building the product that we are building, we're not only able to predict what the current climate conditions would be and going into the future, but we are also set up to be able to predict that if you have geoengineering technologies and if you deploy them, even before you deploy them, you need to have a full scale modeling and impact assessment at each and every location to understand what would be the impact of deploying those solutions from a climate perspective. And then the industries would find that industries, governments, and stakeholders would find additional benefit of studying that from the finance and econometric perspective.
Mm-hmm.
And so our product really would be is a segue to getting there. And that's what we are also very proud of and excited with. And our Arctic Ice Project related research has been presented worldwide, whether it
Let yeah,
is the American.
let's hear about that. What do you think? I was talking to Tom about it. Do you think they're in like it seems like they're kind of in like the testing stages? Do you have models saying because there is the risk of trying to do this deployment and then all the ice just melts and then it's all gone. So I'm wondering
So
what yeah, go
that's
ahead.
exactly the reason we have done at least 4 to 5 years of research on
Wow.
that, and with detailed full scale climate modeling. Detelina can say much more details about the modeling. She has been leading this work. So yeah, I think so far, to the best of our knowledge, it is one of the most benign technologies from a modeling perspective that we know of
In terms of geoengineering, you mean?
in terms of geoengineering, because it is like sand and they have undergone and they're still undergoing a lot of environmental tests about it. But on the math side of it, it does seem very impressive. It does seem to have power of changing the energy balance in a very smart way without having to carpet the Arctic ice with that.
You could
Even
do like
small
focal
regions.
points. You could put focal
Yes,
points in and it will have the same
yes,
effect. It's the
that's what we have
albedo
seen. That right?
positive.
Correct. Yeah. So this has work has been presented at the United Nations, General Assembly, at the House of Representatives in the U.S. Congress, at Davos several times for the World Economic Forum, and of course, many years we have been talking at the American Geophysical Union, trying to
Mm-hmm.
get this work off the ground. But it has shown promise. Detlina, do you want to please add
Yeah.
your insights
Oh
on?
yes, of
Has it
course.
been fun?
This is my
Absolutely.
it's my passion. Yeah, Arctic restoration, climate restoration is my passion, and I'm really striving to get results which are positive. Um, and the thing is, some people were scared when they hear geoengineering, but normally geoengineering technologies are applied over the entire globe, and they do hinder a lot of undesirable effects. So if we, for example, apply the technology over the entire Arctic to cover the entire Arctic ice, that would be a geoengineering. But the idea is that we want to find those strategic regions, for example, like a Fram Strait or Bufurjaya core. I'm talking about geographical names here, but those are strategic regions in Arctic, which if we use this technology, we might have a positive impact. And in my presentation on the last AGU, the American Geophysical Union conference, I showed results that this solution may not stop the Arctic melting, but it will slow it down, and it will allow us to do the actual measures we need to build our greenhouse reduction technologies, and it will give us more time. So I believe that this type of small scale, benign type of solution might help us, and we might need them to slow down the process of either Arctic melt or any other urgent crisis to address. And we might need to use that kind of localized solutions. in addition to the main measures we're
And
taking.
the idea behind that is to stop the Arctic ice from melting because that's going to throw off the entire climate system because it will mess up the ocean currents, right? Which is like the core of
Right.
the
Right.
climate system.
We're gonna shift into a new state, new climate
Yeah.
state, and we have to adjust. Besides that, we already adjusting our technologies to clean up the air and the earth. We also, as human beings, have to adjust to a new climate,
Right.
and maybe it's gonna happen a lot of migration and a lot of things we may don't even imagine.
Right. So, what has been your
Yeah.
experience transitioning from full time research professionals to actual business owners? I know Detelina had said she just went full time a year ago. I take it, Subarna, this was like your project that you kind of started, or you started it together, and she went full time, and now you're both full time. So, I'd love to hear about that before we kind of sign off.
Well, I was working full time till recently in academy in different institutions, and then last year I joined Subarna, who's holding the company for a long time, and it's very exciting experience. I'm really passionate about it, and I feel purpose driven more than ever in my career. So I wish that to younger generations as well to find their purpose and follow it well, step by step till they get to milestones and achievements they're happy with. And yeah,
I love that.
I would let's burn.
Yeah.
Well, I think I am excited because now I have Detelina working with me full time, and we have endless conversations and things to do for each and every part of the business. And the interesting experience for me is when I started this. I mean, we both started this long back, but then Detlina was, working part time in it, and I was working full time. Um, we had no idea of how to run a business, and we were only started with one slide, one DOE, need, benefit analysis, competition, etc. Those kind of slide, and we were amazed and inspired because the moment we left lab, we were mentored. I mean, the lab was still our mentor, and we went through several of these incubation programs recommended by the lab, and we went through iGate, we went through CleanTech Open. And after that experience, that CleanTech Open program, it actually exposed us to all the different parts that you need to have in a business to start. And that experience was like in a, giving us, me particularly, like an MBA in a box. You have a project, you have an idea, you want to take it to the market, you want to get people, you want to get people listen to you, and how do you do that? And what are the different aspects, the legal aspect, the commercial aspect, the market aspect, the customer aspect, the team aspect, the computational infrastructure, every aspect has to be addressed. And so we found that as a very rewarding experience. We connected with some of our, top mentors from that competition. We ended up winning winning the Western U.S. Ag Water Technology category top award for that. But it's only after that we started actually, um, more on a more serious note, trying to build a mock-up of our product, or how it would interact, who we would sell it to. And so that customer discovery process, the process of pitching and getting feedback, we got a lot of very serious comments, but we learned from each one of them. So our patients, particularly, I feel that the exercise that we have gone through has been rewarding because we were always looking to learn from each and every opportunities and not get derailed by all the negative or critical comments, or that comment of you are not there yet as a business, we started absorbing, understanding what those meant. And that has actually really bolstered our way. We have bootstrapped and we have supported ourselves with consulting. Now we have won some prizes. Now we have some customers who are willing to work with us. And so that journey has been a long one and a very rewarding one. And I'm just very glad that we didn't give up. In
Yeah.
spite of all odds, we didn't give up. We kept it going. And I feel our deep expertise in the analytics, during our PhDs and masters and research enabled us to see the dots, to see what lies ahead and what needs to be done, and not get deterred by anything or anyone.
Building your own model for the future.
Absolutely. And I feel that one important thing we must all have in order to succeed as a company, and particularly for people who are scientists like us, is to be able to follow your passion, follow the goal and the vision that you've created, and follow it vigorously. You know, without it, not a single thing has been achieved. It can start as a crazy idea, but we need to be able to execute it. And our years of patience with analytics, with understanding the physics, with understanding the how things work, are helping with that. And that's also a call to all women entrepreneurs,
Awesome.
the younger generation, that you should pick up a problem, and there are enough problems that we need to solve to make the world a better place. And the goal, although you have started a company, is not only to be able to establish a business, but to do a meaningful business that will improve and leave the world a better place, improve people's lives, improve the businesses, improve our sustainability aspects.
Yes, and I think you're definitely doing that. So thank you for that. Thank you for all the research each of you have done over the years to help us understand more about our very confusing yet beautiful world. Detelina, do you have any final pieces of advice for young people who are just kind of getting started in life?
Well, I want to share because I'm very pleased with our interns, undergraduate students from UC Berkeley. We mentor them during their spring semester with our actually solar forecasting project. They helped us with that, and they won the award of the Discovery Program for Data Science Insights. We are very proud with them, and we wish them good luck. And we wish them to be very motivated and purpose-driven in their future, and follow their dreams.
Indeed.
Definitely.
Always follow your dreams. Subarna,
Yes.
Detelina, really thank you so much for taking the time to come on the podcast and share what you're doing. I look forward to seeing how far your machine learning can take the models. It sounds like we hopefully, the longer we go, the more data to collect, the more we'll know. So thank you for the work that you're both doing. I appreciate the time.
Thank you for inviting us.
Thank you for giving us this opportunity. Appreciate that.
You're welcome. All right, everybody. See you on the next one. So if you or anyone else you know is looking to buy or sell a home anywhere in the USA and would like to create thousands of dollars in donations without any cost out of pocket, please visit ccrealty.org today.